The log command in Splunk SPL is a powerful mathematical function that calculates the base-10 logarithm of numeric values. This function is essential for scientific analysis and data scaling operations. Logarithms help transform large numbers into more manageable scales, making them particularly useful when working with exponential data patterns, or when you need to compress wide-ranging numeric values into a smaller, more interpretable range. The basic syntax for using the log command is straightforward. You use the eval command followed by a new field name, then assign it the log function with your target field as the parameter. The syntax is eval new field equals log open parenthesis field name close parenthesis. This creates a new field containing the base-10 logarithm of the specified numeric field. The log function only works with positive numeric values, as logarithms of zero or negative numbers are undefined in real mathematics. Here's a practical example of how to use the log command. We start with a search command to query the sales index, then pipe the results to an eval statement. The eval command creates a new field called log_amount that contains the base-10 logarithm of the amount field. This approach is commonly used when you need to analyze sales data that spans several orders of magnitude, helping to normalize the distribution for better statistical analysis and visualization. Understanding the mathematical properties of logarithms is crucial for effective usage. The base-10 logarithm of 100 equals 2, because 10 raised to the power of 2 equals 100. Similarly, the base-10 logarithm of 1000 equals 3, since 10 to the power of 3 equals 1000. These examples demonstrate how logarithms convert multiplication relationships into addition relationships, which is why they're so useful for scaling and analyzing exponential growth patterns in your data. The log command has two primary use cases in Splunk Analytics. First, it's invaluable for scientific notation applications where you need to convert extremely large numbers into a manageable logarithmic scale. This makes it easier to work with astronomical figures, population data, or financial metrics that span many orders of magnitude. Second, it's essential for data scaling, particularly when normalizing exponential growth patterns in metrics like user growth, revenue trends, or system performance data that exhibits exponential behavior. This practical example demonstrates how to use the log command in a real-world scenario. We search the web index for records where response size is greater than 1000 bytes, then create a log_size field containing the logarithm of response size values. Finally, we calculate the average of these logarithmic values grouped by host. This approach helps analyze web server performance by normalizing response size distributions, making it easier to identify hosts with consistently large or small response patterns regardless of the absolute size differences. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.